Hello everyone, my name is Jiaqi Lun. I am a postgraduate student from South China Normal University in Guangzhou, Guangdong Province, China. I am very grateful to the EAAI20 organizing committee for accepting my paper. I am very happy and honored. I am currently in Hubei province. Because of the coronavirus, I can't leave China and can't personally report to the EAAI20 conference in New York, USA, expressing my deeply apologize. Okay, let's go to my reports. The title of my paper is Multiple Data Argumentation Structures for Improving Performance on Automatic Short Answer Scoring. The author is best for me. It has three co-authors, namely Jiazhu, Yongtan, and Mingyan, of which Jiazhu is corresponding author. The outline of my report is as follows. The first is introduction. The second is back translation structure. And the third is correct answer as reference answer structure. And the fourth is web content structure. And the fifth is experiments. And the final is conclusion. Okay, let's go to the first part, introduction. Automatic short answer scoring, in short ASAS, is a research subject of intelligent education, which is a whole field of natural language understanding. In recent years, the numbers of online educational applications has been growing rapidly, consisting of intelligent tutoring systems, e-learning environments, distance education, and massive open online courses. Automatic scoring short student answers is important for building intelligent tutoring systems. Traditional methods for short answer scoring are rooted in handcrafted features and statistical learning. It consumes a lot of time and workforce to finish this work. In fact, we consider ASAS as a classification problem. For our experiments, it can be divided into two-way, three-way, and five-way tasks. Moreover, many experiments have confirmed that the ASAS system is not good enough because its performance is limited by the training data. Focus on the problem. We propose MDA ASAS, multiple data argumentation structures for improving performance on automatic short answer scoring. MDA ASAS is designed to learn language representation enhanced by data argumentation structures, which includes back translation, correct answer as reference answers, and web content. Okay, let's go to the first data argumentation structure. Back translation. Look at the picture. The first step, we input an original sentence. The second step, generated a translation sentence through the English to Japanese machine translation API. The last step is translation sentence to generated a paraphrase sentence through the Japanese to English machine translations API. To clarify, the target language is not only Japanese, but any language that can be translated. The second data argumentation structure is correct answer as reference answer structure. Look at the pictures. Firstly, the table on the left is an example of the original ASAS dataset, which contains a question, a reference answers, and 3 student answers. Secondly, through the correct answer as reference answer data argumentation structure, 1 out of 3 students receive correct scores. Then we can generate 1 multiply 3 minus 1 equal to new reference students' answers chaining pairs. So we can see that the red mark data in the table on the right is enhanced data. Finally, the ASAS dataset includes 1 question, 2 reference answers, and 5 student answers. The third data argumentation structure is web contents. We use the back translation data argumentation structure to generate a twin dataset. It contains the same question, reference answers, and student answers. For the data of the twin dataset, we carefully examine the original dataset with the left-eyed and find that the meanings of each sentence corresponding to the original data is basically the same. So our twin dataset is reliable. Look at the picture. An example for our web content structure. The question column of original data sets is repeat the question column of the twin data set. So we generated 2 new data sets. The set operations, reference answers, and student answers repeat. Finally, we generated 6 new data sets. The data set Table 1 is our examples of our dataset. It includes questions, reference answers, and student answer. Table 2 is the numbers of questions and student answers and our training and test sets. This is our model using birds on the ASAS task. The reference answer, student answers. Input is represented as a package sentence. The reference answer assigns A embedding, and the student answer assigns B embedding. The change the open source BER model to generate a CLS. The CLS represents sentence features and finally classify it with the softmax classifier. Okay, let's go to the results part. Table 3 is the comparison of the three data argumentation structures on two-way, three-way, and five-way tasks on our dataset. The table 4 is the comparison of our models with previous states of as results on two-way, three-way, and five-way of our dataset. Look at the table 4. Our method achieves states of as results on two-way and three-way tasks. Only five-way was slightly inferior to the ASAS methods, but overall, our method is best currently. This is an urbanization study performed in our experiment. It is found that the biggest factor affecting the BER model is mass sequence length. Look at the table. When the mass sequence length is 19, our experiment results works best. Okay, let's go through the final part. Conclusion. Conclusion is our contributions. 1. We propose 3 data argumentation structures to enrich the training dataset and can help get a better representation of the sentence. 2. Our MDA ASAS combines with the latest fine-tuned BERT model for the ASAS task, which can bring a significant gain. 3. We also made extensive ablation studies and suggest parameters for practical use in the ASAS task. That's all. Thank you for listening. Thank you again for EAAI20 organizing committee.